In this lecture, we will be focusing on a real-world problem, predicting patient no-shows in medical appointments. These are the libraries that we have to import before we start our program. Getting to our first lines of code, here these lines of code reads the contents of the CSV file named medical no-shows .csv into a pandas data frame, and this line of code, which is df.head, the head method is used to return the first few rows of the data frame, which is useful for getting a quick overview of the data, including the column names and types of data in each column. Getting to our next lines of code, here the np.where function is used, which is from numpy. It works like an if-else statement for arrays. The functions checks each entry in the df.gender column. If the gender is M, which is male, it assigns a 1 to the corresponding entry in the new male column. If the gender is not M, it assigns a 0. Essentially, this line is converting the gender information into binary format where 1 represents male and 0 represents not male. Moving to our next line of code. These lines of code creates two data frames, which is X and Y, where Y is target variable and X is features that will be used to predict the target variable. This line of code splits the feature set X and target variable Y into training and test sets. Moving on, in this line of code, MLP classifier is a class from the scikit-learn's neural network module used for creating and training neural network models for classification tasks. This has two parameters. First one is hidden layer sizes. This specifies the size of the hidden layers in the neural network. The number of hidden layers and the number of neurons in each layer are hyperparameters that can significantly affect the model's performance. And maximum iter over here sets the maximum number of iterations the solver will run for the neural network. An iteration in this context is one complete pass through the entire training dataset. Fit method over here is used to train MLP classifier using the training data. Moving on to our next lines of code. These lines of code has predict method over here. It uses the trained MLP classifier to make predictions on the test dataset X test. The predict method of the classifier takes the features of the test data and outputs the predicted labels. In this print statement, we have one method called metrics.accuracy score. This computes the accuracy of the predictions. The accuracy score function compares the true labels with the predicted labels to determine the proportion of correct predictions. In the next block of code, we have another method from metrics module, which is confusion matrix. This method computes the confusion matrix, a table that is often used to describe the performance of a classification model on a set of test data for which the true values are known. In this line of code, we are trying to print classification report. Now, this method called classification report generates a report that includes several key metrics for evaluating the performance of a classification model. The classification report includes several important metrics for each class, such as precision, recall, F1 score, and support. The next block of code is an alternative code for the same which we have printed in our last lines of code. So this code snippet provides an alternative way to display key performances metrics for our MLP classifiers predictions on the test data, breaking down the metrics into individual print statements for clarity. In the last block of code, this command is used to generate descriptive statistics of the no-show column.